properly convey the idea of the efficient frontier, it's useful for me to spend a few minutes just describing what we do at Automate, because this will give you the context that helps you understand why we think the way we do. So our company builds an enterprise workflow automation platform, and our goal is to eventually enable enterprises to become more self-driving, more autonomous, which means lots of automation, lots of human in the loop, lots of intelligent decision making, and all of that. Now, a key component of all of this is the ability to harness the capabilities that generative AI is bringing to us. And in this context, as you all probably know, generative AI is basically powered by large language models. So in this presentation, we're going to focus on these large language models. I'll refer to them as LLMs going forward. And we want to talk about an idea or an infrastructure that we provide for you to properly engage with LLMs and derive the benefits of lower cost, ironclad security, high speed, and responsiveness, and quality of results. So at the high level, what do? We hyper-automate enterprise workflows with Gen AI, and this is similar to what I just said. We're an enterprise workflow automation platform, and we've infused Gen AI into every aspect of our platform. So I wanted to start by giving you a high-level view of how we look at the world of automation. When we consider automation, we are looking at it from the perspective of a customer journey. And if you look at a customer journey is basically any interaction that a customer has with an enterprise. This could be something like customer support, where they have questions about a product they purchased. It could be around something more complicated, like applying for a loan, where they have to provide a bunch of information about their qualifications for the loan. It could be in a healthcare setting, something like getting consent for surgery and things of that sort, where you can do a lot of document signing online in a consistent way, so that you can mechanize these aspects of it, so you don't have to spend as much time as you might need to at the hospital. So we think of all of these as customer journeys. And if you look at every customer journey, they have three important components. The first one is what we call intake. And this is the mechanism by which the customer conveys to the enterprise what they want and any data that supports it. This comes through many different channels. And we have conversational AI, which is chatbots, and we have email automation. Both of these are powered by Gen AI in our platform. Once the information is received by the enterprise, they get into what's called a fulfillment mode, where the data supplied by the customer gets sent to a back end, to a back office, if you will. And this sets into motion a bunch of different workflows. Here again, we've got Gen AI helping you design these workflows in a low-code kind of environment. And eventually, you have analytics that's continuously monitoring the operation and giving you insights in real time as to what's going on with these customer journeys. Here again, we use Gen AI to give your business analysts the capability to look into the analytics, detect, run queries on it, get reports from it, and do things like forecasting, anomaly detection, and process mining, which tells you where in your customer journey people may be getting stuck. So based on that model, we've created, you can consider it a suite of different products, low-code products. We have front-end products that help you build apps, that help you build chat conversations. And we've also got a human agent platform, which is kind of like a lightweight contact center. And on the back end, we have a bunch of different capabilities around creating these fulfillment workflows that are based on business process management, and maybe if you've heard the term BPMN. All of this is contained within AH Studio, which is the umbrella platform, where you can open it up and start designing these workflows, connecting them together, and we give you a large collection of building blocks to get going. And these building blocks would include adapters to different systems, like, say, ServiceNow for ticketing, Salesforce for CRM, Okta for authentication, and things like that. Finally, A8 IQ is our analytics engine. And across all of these products, we have Gen AI enabled. So you have the ability uh, do to perform your tasks by just describing in natural language what you want and having the system do a lot of the heavy lifting for you. So in other words, we've taken low code even closer to no code. So now if you let's talk about Gen AI and broadly, the hurdles that most enterprises have when it comes to looking at an idea and seeing the magic that Gen AI can do and actually deploying it in an enterprise setting. There are three key considerations that the enterprises have. The first one is how do you integrate Gen AI into the existing infrastructure? How does it integrate with legacy tools and things like that? The second one is around cost. While it's reasonably cheap to run a few experiments and send a few queries to these large language models, uh, the reality is that these costs can add up pretty quickly. And there's a wide variety of cost differentials between models. And so, it's always useful to be able to manage that and make sure that you're getting the maximum value for your money. Finally, and most importantly, perhaps, enterprises are worried about leaking information to these models. So anytime you use a third-party model, what you're doing is you're sending a collection of information to this model, and it's returning a response. But within that payload that you send to the model, you want to make sure that there's no leakage of your corporate IP, there's no leakage of personal information, and things of that nature. So for the rest of this conversation, I'm going to focus a lot on the Gen AI aspects of it. So just at the high level, there are two key objectives of generative AI as they apply to the platform that we offer and to the kinds of problems that enterprises are solving. The first one, like I said, was moving closer to no code. Use Gen AI as a productivity accelerator within the low code platform that enables low-code developers to state what they want in natural language and have the system do the work for them. The second part is to actually manage costs, manage security, quality, and responsiveness. And it's to solve this problem that we built an infrastructure that we're calling efficient frontier intelligence. So that's going to be the bulk of the conversation today. I'm going to talk about efficient frontier. I'm going to talk in some depth about cost management, security, and quality, and all of these things. So let's talk about efficient frontier and start with a definition of what this means. In the world of investing, an efficient frontier is basically the set of stocks that you own in your portfolio, along with how you buy and sell these stocks in order to ensure that you're meeting your investment goals. So that's called the efficient frontier. And the efficient frontier is actually a name to describe the graph that shows you the frontier of your investment, the value of your investment at any given time, and how the buying and selling of stocks can ensure that the frontier remains in compliant with your risk reward objectives. We are building a similar kind of infrastructure, benefiting from the theory of efficient frontiers. We are building a similar kind of infrastructure for you to use models. We have access to a bunch of different models, and we have an infrastructure that takes care of using the right model for the right task based on maximizing security, based on minimizing cost, based on a high quality of results, and based on the speed of response. So basically, if you think about this, what this boils down to is that just like you diversify stocks in an investment scenario, we give you the ability to diversify models in a Gen AI, in the world of generative AI. And many companies like Google and Microsoft have acknowledged this because they offer these catalogs of different models that you can use while deploying into the Google Cloud or the Microsoft Cloud. The key point here is you want to use the LLMs that are best suited for your problem statements. And what I've put up on the screen here is a collection of different models that do different things well. There is no one model that does everything well. So for example, if you want responses, say in a customer support scenario that are instructional, you can use models like Mistral and Zephyr, which significantly outperform the well-known guys like the OpenAI or Google. Likewise, if you want to use RAG, which is a technique for having authoritative information, reducing hallucinations, Google provides a wide variety of tools, and so on. So you have many different tasks for which you need to you have different models that do a good job. And what we do is provide you with the infrastructure that will pick the right model and run the query for you on that model. So let me dwell a little bit on this diagram, which shows the efficient frontier intelligence infrastructure. The way it works is that you as the customer can deploy your chatbot or your email automation or whatever is the tool that you want in a customer support scenario to your users. You do this on your website, through your app, or whatever is your appropriate channel. Now, anytime a user asks a question, the question is sent to the Automate tenant that is sitting in your cloud. By default, we use the Google Cloud, but this tenant can sit in any cloud. And this infrastructure does a few things. It minimizes the cost and security and quality and speed and maximizes your quality and speed, just like I described before. But the other thing is that it contains all your content and all your data, and none of this leaves this infrastructure to a third-party model. So the third-party models have no visibility into customer data when you use our infrastructure. I'm going to get into some of these techniques in a little bit more detail, but the key point is that this tenant houses all your data completely and nothing leaves it. So if you look broadly at the generative AI toolkit that we provide the efficient frontier, as I described. And then we also, here's a list, the current list of models that we support. There's 18 of them. And we expect to grow to many more by the end, on an ongoing basis. When it comes to Gen AI capabilities and use cases, we provide conversational AI, document AI, which is the ability to say summarize documents and do things like that. Computer vision, which is the ability to look at images and make sense of them. And a whole bunch of tools around content summarization, data extraction, multimodal tools that allow you to feed into them images, text, videos, and all of that, and combine them together as kind of a data source. And finally, the platform that we offer is omni-channel. In other words, you can leverage Gen AI through an app, through chat, through a contact center, through email, and all of these different places. And it's a multi-cloud capability. Yeah, so while Google Cloud is our default cloud, this entire infrastructure can be housed in the cloud of your choice. So at this point, I'm going to get into a few demos. I just wanted to say that we'll go through this entire presentation kind of at a stretch and give you the opportunity to ask questions at the end.
Awesome, Ranjit.
So yeah. All right. So one of the first demos I wanted to show you is in terms of using generative AI to improve the productivity for low-code developers. So what that means is that you can express what you want in natural language, and the system, for example, in this case, will generate workflows for you. Based on our efficient frontier infrastructure, we have picked Google PaLM 2, which is a slightly older Google model, as the best model for this purpose. It allows you to do fine-tuning. It allows you to do, it is very responsive, much faster than some of the other more well-known models. And it has, it's available at a very low unit cost. And so the approach we use is our own proprietary techniques, including what we call prompt synthesis, which is we construct prompts from your data, and our own proprietary middleware. And this is the industry's first generative AI workflow builder. So I'm going to show you how this works. So let me jump into another screen and just give you a visual of our, this is what our low-code workflow builder looks like. At the moment, it's an empty canvas. So what I'm going to do is copy this particular set of instructions, which is to create a workflow for a travel booking process. We explain, what we should do in terms of what are the steps involved in the workflow and all of that. And so I'm just going to type that in. So in this case, so you can think of
Ranjit
this.
Sorry to interrupt you, but would you mind just maximizing the left side of the screen a tiny bit?
Oh,
just so that it becomes. Sure.
Here we go.
Perfect.
All right. So I'm just going to hit return on this. And so what's going on is that we have we've submitted a natural language description of a particular kind of workflow that we'd like to have. And what the system has done is it's creating a it's created this on the fly for you with a bunch of different steps. So you'll see that, we just indicate this rather sketchily in the description we gave, but we said select destination, choose dates, book flights, etc. And the system has done a few things that are interesting. First of all, this workflow is relatively linear, so it's built a linear workflow. But in addition, the system has also figured out which parts of these need user input as designated by the purple boxes, and which ones are actually services where you need to actually run some code or do some automation to make that thing happen. So there's that level of intelligence in the in the system, and I can show you another couple of examples. But before doing that, let me actually let me show you another example first. So let me come back here. I will. Sorry. I'm going to minimize this, go back to my presentation, and try the next one, which I'm going to first show you in slideshow mode. But this is a much more complex prompt. This is for, you can say it's a lightweight loan origination system, but we've described what the loan origination system should have and all of these kinds of things. And so what I'm going to do is copy paste this description into this. So let me open this again, full screen. Let me undo and clear what we have on this to get back to an empty canvas. Clear this. And I'm also going to choose GPT-4 as my model. Let me just type in this. I just copy pasted the entire text in here, and I'm going to let this go. So this takes a few seconds, and while that's going on, let me explain what we're doing here. So what we've done is we worked with Google to build this particular workflow generation application. We've created a custom model that understands workflows, that understands BPM, that understands BPMN, which is the underlying standard. Based on that, we take the prompts and we can send it to any model. Previously, I sent it to Google. I'm sending it to OpenAI at this point. The model returns an abstraction of the workflow. We then take that workflow and then using our middleware, we convert it to BPMN. And finally, that BPMN gets rendered on the screen in our low-code tool. So within a few seconds, you should see it start getting rendered. Again, in this case, the point here is that we can show you many different types of. Let me just shrink this a little bit. We have access to many different models, and in this case, we found that for the somewhat more complicated workflows that involve multiple branching and different types of nodes, GPT-4 was a better model. So in this case, the user has the ability to select it, but we could do this dynamically, where based on the prompt workflow that came in, we would select the model that was most appropriate for that and generate it. The downside of GPT-4, as you have observed, is that the performance is relatively slow compared to the Google model that we used previously. And the second point is that GPT-4 is significantly more expensive. So I just wanted to show you this. And I'm going to show you a couple of other capabilities here. I'm going to just click on this and create a service. So let's say I want to create a service, and I'm just using an existing service for this. So this opens a new window. And I'm going to come back to this in a minute. And this shows you the code generation capabilities of the platform. I'm going to go back here, jump back into my PowerPoint presentation, and I'm going to write some code. As you can see, this is the code that I'm going to write. The first line of this code is specific to our Automate SDK. So we have created a custom tuned model for code generation that is tied to our SDK and our library and our packages. And then I'm going to call the ServiceNow API, create a ticket, take the incident ID from that, and write it into Salesforce. So that's the code that I need to write. So I'm just going to copy this. I'm going to come back into my code generation page, open it up, and paste that in here. So this is, again, the idea that Gen AI can be used in a way where the user can get a significant productivity boost by just writing in natural language what they want, and the system is able to generate what they need. A pretty important point here is that the system will generate code that is specific, that can run within the within the Automate ecosystem. And it's giving me all sorts of descriptions, because obviously it doesn't know my password, it doesn't know the column name or the field name for Salesforce, it doesn't know the name of my Salesforce instance and all that. So what the system does is it's prompting me to enter that piece of information. But here, for example, it's using the A8 data module, which is specific to Automate. And so this is made possible by the fact that we custom tuned this model to be able to generate code that's specific to run, that will specifically run in our ecosystem. So that was the first thing I wanted to show you. Let's move on here with the presentation. The second demo is showing you, the capability to track all of these, cost and performance and quality and all of that in our LLM dashboard. So in this case, we have an LLM tracker that has, we have a backend that supports a bunch of different models. And as people start using these models, we can give you real-time metrics on cost, performance, and quality. And these are the models that we're using. In this case, we have a real-time dashboard that shows that adapts to your business KPIs. So if you're focused, for example, on cost minimization, we would choose the appropriate model for that as well. So let me jump to the screen and show you what that looks like. So this model now shows some useful information. It shows that we've run 1,500 prompts so far. The total money we've spent is $41 US, which is a significant amount of money, for 1,500 prompts. So you can see how the multiplicative effect of using these models can really impact your budget. One thing you may notice is that GPT-4 is a huge percentage of this amount. There's a bunch of different models, and we have a leaderboard that shows you, both the response time, and so there are a few models by Grok and others, and I'll talk about these models in a second. And then there's a few open source models like Llama and Mixtral. And you can see that certain models perform very well, certain models have low cost and things like that. So what I'm going to do is now, just behind the scenes, I'm just going to run a few queries that's going to randomly select a particular model and update this information just to give you in real time. So I'm going to run 10 queries, and I've started the process. And what this dashboard will do is update in real time as these queries get run, show you, the cost and the model that's being used and all of that. So, for example, the most recent one we ran was Llama 70B. It took about 14 seconds, and we're just picking these questions out of a random list. So as you can see, the system continues to run. Now, let me speak a little bit about these different models. So Google has the Gemini Pro, which is the the most powerful model that they have now. And more recently, it's been enhanced to support a million token context window, which is a huge amount of space for you to create a prompt. Text Bison is one of their older models, and so on. We have 3 GPT models, including Turbo, GPT-4 Turbo, which is interestingly enough less expensive than GPT-4. And then we have Mistral, and Llama open source models. We also have a couple of models that are served by a company called Groq, Groq, and these models are hardware based. So they give you super high performance and they've got a significantly low cost. However, they are not as good as some of the more mature models like GPT or the Google Gemini. And I'll come back to how, different ways to use these models in a bit. And then different quality capabilities like fresh data, like Sonar Medium Online gives you fresh data. So for example, most models are know only up to the point that they were trained, whereas some of these newer models actually are continuously harvesting information so that they can give you news that's maybe even just 24 hours old. And then we have the 3 important models from Anthropic, which is creates really excellent models to do code generation. You can take a picture of your screen and it'll interpret things for you and all of that. So these are just a bunch of different models that we're using, and I just wanted to show you the ability for us to send queries on an ongoing basis to these models and have them and have an ongoing computation of cost and performance. We also measure quality, and in that context, the Groq models are interesting because if one of the benefits you have when you have cheaper models but very fast models is that you can use those to actually train the more complex models. So let's say I'm building I'm fine tuning a particular model that I'm using, let's say with Google. I can use there's a technique called distillation where I can have kind of a student teacher model where the the teacher model can run a whole bunch of queries and create examples that are then used by the student. I hope I said that right. The teacher creates a bunch of examples that are used by the students. And since you're running a whole bunch of queries, you can run them on these lower cost models. So there's many different benefits of having a wide variety of models to choose from. All right. So just wanted to show this to you. I'm going to jump back into the presentation now.
Yeah, there are a couple of questions which have already come up, Ranjit, but
Yeah.
I presume you would probably need a couple of demos before you take this in.
I can take them now actually. If could you read them out for me? Sorry.
Sure, I could take the first one if you wouldn't mind.
Yeah.
It is about, so the attendee is anonymous, but I will ask it anyway. It's about how do you measure the quality of a response from an LLM model?
Okay. So when when a model responds, there are many different ways to measure the quality of the response. So they broadly you can classify them into what are called objective measures, where you measure you have a known data set against which you measure the performance of the model, and you can very you can calibrate the capability of the model really well. So there's tools, there's measures like perplexity, which measures kind of your ability to find a specific chunk of text in a large document based on a question. There's obviously accuracy, which is pretty easy to understand, which is how accurate was the data how accurate was the response compared to my data set. There's other sort of well-known mechanisms like Rouge, which is similarity. How similar is my response to a data set, and BLEU blue, Meteor, and things like that. Those are objective measures of quality, which are all based against a used data set. There's also many subjective measures of quality, and those are harder to gather, but I think important. Every time you get a user to provide feedback on these measures, it's super useful. So these would include what was the usefulness of the response? How complete was it? How correct was it? How relevant was it? How fresh was it? And then there's sort of a next order of subjectivity, which is this solution harmless or harmful? Is the solution ethical or non-ethical? So you can get into a whole collection of ways to measure the quality of the model. So hope that answers the question. Any others, Ranga?
Yeah, so we have one more, and I think you partly answered that during your most recent demo. It's about how
Yeah.
to decide which LLMs are made available through our infrastructure.
How do we decide?
Yeah,
Yeah. Okay. So what we do is, so we generally follow the leaderboards. There are some really significant leaderboards that are out there, including Hugging Face and others. So what we do is we track the leaderboards and we pick the model based on how well known it is and how high up it is on the chain. So we only recently added the Claude models because previously Claude was on model 2.1, which was kind of middle of the pack type capabilities. But more recently with Claude 3, we have they've raised up the leaderboard to be really important and capable. So we added them immediately to our infrastructure. It's pretty easy to add new models to our infrastructure because by and large, most of these models are exposing similar kinds of APIs, but that's what we do. So we just follow some of the industry type leaderboards. Anything else from that, or should I keep going?
no, no, I think that probably answers the question. Thank you.
Okay, great.
You could continue with your demos, and I will probably chime in any questions that come to the end.
Okay, yeah, I don't have any more demos actually. I just have a bunch of slides where I want to talk in some degree of depth about cost and security.
Sure, we don't have any more
So
questions, so you could continue with those until we have more by the end of the
got
session.
it. Sounds good. Okay, thanks, Anand. Okay, so just wanted to give you a bird's eye view of LLM pricing as of a month ago. Things keep changing. I know, for example, that the Claude models have gone to a more uh, you know, uniform price structure and not with this much difference. I think GPT-4 has have reduced their price for certain situations and then things like that. But this gives you a broad idea of which models are generally more expensive and which ones are less expensive. I just want to touch briefly on one point here, which is on this screen. I wanted to highlight, and maybe this is hard to see, but I'll read it out. You have the Grok and the two Gemini Google models at the top of the list when it comes to the average response time. So these are super fast models. Now, here, in terms of cost, you have the Geminis and the others slightly in the middle of the pack. So they're not as inexpensive as the Grok models or the open source models, but they're here and they don't go off the curve exponentially like some of these do. So I think this starts to give you an idea that if you want to deploy your own LLM, where's a good point to start looking for a cost-effective and a performant type of solution. Okay, so coming back to this. I want to talk about how cost gets managed. So as I explained, the challenge is that the cost for these things add up very quickly because they're based on the number of tokens you send. And if you get a long response back or you send a very long prompt, you're racking up the charges. So you want to be able to manage your spend and optimize your quality and all of that stuff. Our platform provides many different techniques for doing this. So, for example, uh, while the world Gen AI is the new shiny technology, the more traditional NLP based technology or intent based technology is something that we already have a very powerful foundation for, and the likelihood is that many of the questions that you're asking can be answered by this intent-based technology. And so you can save money by using those. So we can route appropriately to those services when we don't need the power of a generative AI solution. By dynamically selecting the LLM, we can keep your costs low. We provide out-of-the-box caching. So you can say that, okay, any question for which I get a response back, I want to cache it for a day or whatever you want. The other thing we do is that in certain situations, you want to actually use the data that comes back from the model to fine tune your own model, perhaps. So in those cases, we can actually have the data come back through some sort of curation workflow into your fine tuning module, and you can use that to fine tune your own models. And a key point about fine tuning is that, or I'll get to this in a couple of slides. I'll talk about fine tuning in a couple of slides. So let me now touch on security. And I'm going to go into security in a little bit of depth because that's always the most important concern that people have. You want end-to-end data security and protection across. You don't want your corporate IP leaking into these third-party models. You want to protect user identification, PII, and you want to minimize misinformation or harmful information from the models. So we have a bunch of different capabilities to do this. Obviously, basic, all data is encrypted. The second important one is on PII protection. We have a bunch of different techniques that can detect and treat PII within your document. And this includes just redaction, pseudonymization, which is basically replacing a name with a different name, generalization, which is like bucketing, so if my age is 42 would then be bucketed into my age is between 40 and 50. Swapping, which is a technique to, so, for example, if there's 3 tiers of loyalty program, blue, silver, and gold, and I say I'm blue, I can just swap it and say I'm silver instead, just to mislead. If that particular information is not important to the context of the question, we can swap it and not disclose any more information than is needed to the model. Perturbation is the idea of adding a little bit of noise, which basically means change the numbers a little bit, change most numerical values a little bit. We reduce hallucinations by using an approach called grounding. And grounding basically means you construct your prompt by looking up authoritative data that could come from a search engine, it could come from a knowledge base, or any of those different places. And finally, we protect your IP by using techniques like model customization and fine tuning. I'll talk a little bit more about these in a second. So we provide a framework for PII treatment. And the way, so it looks kind of like this. So you have a configurable framework where you can say that anytime there's a person's name in a document or in a prompt that's sent to a model, you can pseudonymize it. If there's an email address, you replace it with asterisks. If you see the name of a company, you can just replace it with the entity type. I'll show you an example. And finally, if you see a phone number, you can just replace it with the last 4 digits, for example. So just to, and here is kind of a description of what these things mean. We use these techniques. In addition, we can do encryption, which is basically means encryption implies that it's a two-way function. Once you encrypt it, you have a key based on which you can decrypt it. The second one is hashing, which is a one-way function where you can only encrypt it, but once hashed, you won't be able to recover the original, and this may be useful in certain situations, and so on. So these are the different techniques that we use. In this context, I wanted to show you a couple of simple examples. So let me just start with this. So let's say I have a document that looks like this. Oh, okay, that's not easy to read. This may be easier to read. So yeah,
if you can, Ranjit.
Yeah, let me do that. Okay. Oops, sorry about that. Okay, so this is a document that gives you my name and where I work and our company address and phone number and a price and my email address. So this is the input document. Well, once you apply the treatment on it, and here again, the treatment is you pseudonymize persons' names, you change email address with asterisks and things like that. So you give the system these um, directions on how to treat information. What ends up happening is that the system is able to do a full anonymization, change my name, redacted organization address, replace my email with asterisks, and kept just the last 4 digits of my phone number. So this is an example of where you can apply redaction at the query level. Another example is where you can apply redaction to a full document, and that's what we've done here. So we had, a technical document, a contractual legal document, and when you run it through anonymization, it removes a lot of the information on the organization. It removes, so as you can see with the highlights, it's removing certain kinds of information and replacing it with just the name of the entity. And this is very useful in a legal kind of environment where you can exchange documents or even actually send some of these documents to third-party models, knowing that all the personal information has been redacted. And so you can see that you're replacing organization names and things like that. And here, for example, you've pseudonymized a couple of names. So these are not the actual names of the people, but they're pseudonyms that have been created on the fly by our system. So I wanted to touch on that. Coming back to the presentation. So this gives you an idea of how we protect PII. A significant and powerful technique is de-identification. The second part is in terms of IP. And here's where I wanted to spend a couple of minutes talking about fine-tuning models. So when you create a prompt that you need to send to your model, there's a few different techniques. You can put everything in the prompt. So what you do is you tell the prompt to do certain things. I mean, you instruct the model to do certain things. You put your prompt in there, and you maybe give a few examples. That's called few-shot training and things like that. You can give some examples in the prompt. The second approach is to do grounding with a technique like RAG, where you look at some authoritative data, construct the prompt from that, and send that over. The third approach is fine-tuning, where you create your own version of, you kind of influence the actual model by creating your own fine-tune, and the term that's used is an adapter layer. You create an adapter layer that sits between your query and the model you're sending the query to. So in some ways, any query that you write goes through two steps. The first one is where your adapter layer treats your query in a certain way. And it's very useful when you have certain rules or certain jargon that's specific to your organization. Or more importantly, if you want to introduce certain subjective preferences, I guess bias is a word you might, that is specific to your organization into the system. And the other, you can go through this layered approach to querying models. So your adapter layer is your private layer that customizes how the model behaves, and then once customized, that information gets sent to the actual core model. When you do this, the data parameters and your adaptive layer sit in our tenant in the cloud. They don't go to the third-party model. So in other words, the best way to protect your corporate IP is by creating an adapter layer and fine-tuning your own model. And so that way you get a lot of protection. And so, there's many different types of functions for which this is useful. But this comes with many benefits. So, for example, you have situations where someone can try and fool, a model by asking what seems to be a simple question, but then at the end, ask about, say, how do I pick a lock, or how do I make a weapon, or whatever that is. When you fine tune it, you can actually have significant control over how you curtail this kind of maybe adversarial or garbage input that needs to go to your model. There are other benefits as well. Since you're not putting these few short examples in your prompt, you're saving money on the token cost. You can potentially even use a smaller model. Instead of a 175 billion parameter model, you can maybe do just a 100 million parameter model, and you get better performance. So there's lots of benefits of custom, fine tuning. And just to kind of give Google a shout out here, when you use the Google tools, there's no extra cost for using these tune models. There's a little bit of upfront effort where you do the equivalent of your few shot training to create your custom model, and then once you do that, the information, you can keep that and grow that and keep it private and not give away your corporate IP. All right. So I've covered most of what I wanted to cover, but I just wanted to spend a few minutes talking about some of the other use cases that we have. So we have, for example, Gemini Pro is really good at assessing agent transcription. So I can look at the transcript of an agent's conversation with the customer and evaluate how well they performed, whether they were rude or polite, whether they addressed them by name, whether they pitched what they were expected to pitch. So basically, you have a rubric against which you can evaluate the agent performance. And Gemini Pro has been the model that worked really well for this. When you look at the world of fraud detection, especially in the banking sector, you have many different types of fraud. Fraud which is assisted by the customer, fraud which is not assisted by the customer, romance scams, all these different kinds of things. And so there's a classification rubric, and based on this classifier, we found that OpenAI GPT-4 does an amazing job of looking at a conversation between a customer, a banking customer, and say a support agent, and making a decision on whether there was any fraud vulnerability or actual fraud that this customer may have a propensity or an affinity towards. There's other tools that we use, and here the Google Palm 2 model is awesome for extracting data from forms. So a typical use case is where you can throw into the system an invoice and a purchase order, and the system will automatically figure out if the purchase order matches the invoice or if there's some discrepancy, which then can be flagged into a backend workflow for someone to come and take care of. There's many tools for email automation. Again, Gemini Pro is our tool of choice, our model of choice here, and so on. So that's just wanted to cover all of these different points, showing you that there's a richness and a diversity of models out there, and the efficient frontier is our recommended approach for you to leverage the best that each of these models can offer. That's all I had, Ranga, so we can get into any questions if you want.
No, that's great. And I believe while you were discussing the fine-tuning section, you partially answered the next query that came in.
Yeah.
The query was about how can I integrate my own fine-tuned model into your platform? And I believe you answered that partially, but would you add to that specifically with regards to integrating a third-party created LLM into Automate?
Yeah. So the way you would do it is, so there's two types of models, and I can come back on video here.
Yeah, that would be great. And you could probably stop sharing as well, Ranjit.
Yeah, let me do that. So there's a couple of different ways. One is if you have a complete model that is running on your own hardware, all you have to do is provide us with the typical type of API that any model would use, where you specify the user, where you can provide a system prompt and where you can provide user prompts, and then we can integrate very easily into that model. The other option is for you to give us a set of examples to fine tune one of the models that we recommend, like maybe Gemini Pro, and and build a fine-tuned model for you. So that's those are two ways in which you can uh, personalize the model, if you will, to the needs of your enterprise.
That works, Ranjit. Thank you. And I think the last one, we were discussing about various ways of redacting data and different types of security too. But I
Yeah.
think the question here specifically is to how do you protect against prompt injection attacks? Uh,
Hmm.
I will leave it to you whether you would
Okay.
discuss this as relevant to our platform or not.
Yeah, I think so. So a prompt injection is similar to the kind of injection attacks that you may have seen in the world of SQL, or that you may have seen in the world of even chat, where people can cross-site scripting, for example.
Right,
So what happens is that people, someone can put in a prompt that can actually get executed. So, for example, if you're doing SQL injection, what you might do is there's a SQL statement that says delete star from incident or something like that.
right,
You can actually stick that into your input, and if the system's not careful about parsing the data that comes in through the prompt, it'll actually execute that and could potentially damage data on the back end. So in the same way, prompt injection is where someone might ask a simple question, but at the end they append something sinister or harmful, uh, by asking a question that is completely uh, off topic or something like that. And then that can fool if you have very basic filters, then it can fool the filter into actually accepting the whole query and then sending the model, a harmful question like how do I pick a lock or something like that. So what we do is we provide a couple of techniques. We do what's called prompt sanitization. So we look at the data that's contained within the prompt, and and using actually our fine-tuned model, we can actually remove anything that's outside a certain topical boundary. And the second part is we also provide tools for users to be authenticated. So if there's a situation where something is not public, where a tool is not public, we can authenticate the user to make sure that that they're tracked and that they don't abuse the system. And finally, we do prompt optimization. Quite often, if your prompt is too long, or we make a determination that it's not optimal for the question you're asking, we will compress it and change it. So these are the different approaches that we use to minimize prompt injection.
awesome. And I think we might probably not have too many CRUD operations happening on the prompt level, but still, it would be good to know that we do have these safeguards in place to
We do have
prevent such
safeguards.
end-to-end. Right,
Absolutely. It's always kind of a back and forth game with people who want to harm the system. So you put
right,
these in place. Someone might decide that they can try and attack your prompt after it leaves your cloud and goes to third parties, man in the middle type attacks. So
right.
for that, you try and use encryption. The backend models are also putting safeguards in place. So you could send a checksum where I will, put a checksum on my prompt. And if that checksum changes, the backend system will know that the prompt's been tampered with and will ignore it, things like that.
Right, right. No, that's good to know. And I'm glad that these questions are being discussed so that people are able to share what they know about being able to safeguard in spite of having LLMs at your beck and call. But I
Yep.
think that's about the number of questions. I'll just quickly answer this one as well, just to see if there are other questions. I think that is it. Any other points from you, Ranjit, before we decide to close this session and call it a wrap?
No, I think that's it. And I would say if you like what you heard, get in touch with us and we can help you, get enterprise grade generative AI into your company.
Awesome. And for the folks who probably joined in late and did not hear the entirety of the session, don't worry. This session has been recorded from start to end. So you would have access to the recording, the slides, the questions. But if you still need to ask any specific query to Ranjit, feel free to reach out to us when we send out the recording, and we would be happy to discuss and potentially have a tailor-made demo for you if you're so inclined. Yeah. But thank you so
Great.
much for your time. Thanks for joining us again. And thank you, Ranjit, for hosting this session. Have a great day.
Yeah. Thanks, everyone. Thanks, Ranga. Bye.
Thank you. Bye.